There are moments in science when a single discovery fractures our sense of reality, when data, not speculation, forces us to confront possibilities we never expected to face. Tonight's story begins with such a moment. It starts not with a rumor or an unexplained image, but with a precise mathematical analysis that has sent shockwaves through the astrophysical community. The subject of that analysis is an object known as 3I Atlas, an interstellar visitor whose behavior and trajectory have defied every conventional explanation. For months, astronomers have watched its silent passage through our solar system, its faint glint moving against the tapestry of stars. At first, it seemed to be just another object passing through, like Oumuamua years ago, a shard of alien rock wandering between the stars. But data rarely lies, and when the first orbital calculations were refined, something began to feel wrong. The numbers didn't add up. Its motion through space didn't follow the patterns we know from comets, asteroids, or debris ejected from dying stars. It moved with a precision that shouldn't exist in nature. At the University of California, Berkeley, Dr. Sarah Chen and her team began the long process of retracing the object's path. Using the most precise data sets ever collected from ground-based and orbital observatories, they reconstructed its journey backward through space and time. What they found was, at first, dismissed as a computational error. It had to be. But then, 3 separate methods, direct n-body integration, Monte Carlo sampling, and machine learning predictive modeling, all converged on the same improbable conclusion. Somewhere in that convergence, amid the raw noise of cosmic motion, a story began to emerge, one that stretched across millions of years and hundreds of trillions of kilometers. The story suggested that 3I Atlas was not merely passing through. It had a point of origin, a destination, and possibly a purpose. Imagine tracing an invisible line through the dark, following it backward through the Milky Way until it intersects with a single system among the 400 billion scattered across our galaxy. 270 light-years away, that line stops at a sun-like star known as HD 43782. It is a G-type main sequence star almost indistinguishable from our own, burning at a temperature within 200 degrees of Earth's sun. Its mass just over 1 solar mass. Its age slightly greater than our own systems. To the human eye, it would appear the same golden light, the same quiet warmth. But the line doesn't stop there. When the simulations were run in reverse, accounting for galactic drift and the gravitational fields of nearby stars, the data showed something impossible. The object hadn't been randomly flung from its parent system by a collision or gravitational slingshot. It appeared to have been accelerated, deliberately. That was the moment the tone of the analysis shifted. This wasn't a natural object behaving under natural laws. This was something else, something controlled. The implication was staggering, that an object had been launched from that system roughly 2 million years ago, set on a precise trajectory that would bring it here, to us, just as our civilization reached the stage where it could finally see and understand it. Consider that timescale. 2 million years. When 3I Atlas began its journey, the first humans were only learning to use primitive tools. Our world was a place of forests and thunder, inhabited by early ancestors who had yet to shape fire or language. Across that same expanse of time, this object, whatever it is, was already crossing the emptiness between the stars, silent and unyielding, carrying with it the intentions of something or someone beyond our comprehension. It is easy to romanticize the cosmos, to imagine distant civilizations and the beauty of discovery. But what happens when that beauty carries a purpose? What if this isn't a coincidence of cosmic motion, but an act of deliberate design? Dr. Chen's team hesitated before publishing their results, not because the math was uncertain, but because the implications were too heavy to grasp. Independent groups from the Max Planck Institute and MIT confirmed the same data within weeks. The trajectory was consistent. The origin matched. The conclusion could no longer be dismissed as computational noise. 3I Atlas came from a nearby sun, and the probability that its path was the result of a natural ejection was vanishingly small, almost zero. What does that mean for us? What kind of civilization could launch an object across hundreds of trillions of kilometers and have it arrive intact, functional, and precisely timed to our technological awakening? As this story unfolds, we are forced to confront not just scientific curiosity, but existential awe. Somewhere, 2 million years ago, intelligence looked outward across the dark and chose a destination, our sun, our home, and now that messenger has arrived. What it wants, what it carries, and why it came here, those are questions science is only beginning to ask. And as we look deeper into the data, into the strange behavior of 3I Atlas itself, the answers may redefine what it means to be human in a universe that suddenly feels much less empty. When the data from Berkeley reached peer reviewers, it was accompanied not by speculation, but by a meticulous stack of figures, orbital parameters, error margins, and probability distributions that told a single, haunting story. Dr. Sarah Chen's team had done what astrophysicists do best. They let the mathematics speak. 3 independent models, each constructed from different computational frameworks, pointed in the same direction. The object designated 3I Atlas did not emerge from random celestial mechanics. Its trajectory through interstellar space bore the unmistakable fingerprints of design. In the days that followed, observatories around the world reoriented their instruments toward the object's position. The Very Large Telescope in Chile, the Keck Observatory in Hawaii, and the James Webb Space Telescope all gathered data simultaneously. Spectroscopic readings indicated a composite structure, unlike any known asteroid or comet. Instead of the typical silicate or carbonaceous spectrum, there were irregular absorption lines suggesting the presence of ultra-dense alloys, materials theoretically possible, but never observed in nature. Even at this early stage, scientists began to whisper what none of them dared to say aloud on record: this might be an artifact. At the Massachusetts Institute of Technology, Dr. Helena Foster, a veteran of the New Horizons mission to Pluto, was among the first to compare 3I Atlas with other interstellar objects. Her focus naturally turned to Oumuamua, the cigar-shaped visitor that had puzzled astronomers in 2017. Oumuamua had shown slight acceleration, inconsistent with gravitational forces alone, but it could still be explained by sublimation of ice or dust jets. 3I Atlas shattered those comparisons. Its motion was too clean, too calculated. Its entry vector was aligned almost perfectly with the plane of our solar system, a plane that moves, twists, and oscillates over millions of years. To achieve such alignment, whoever launched it would have needed to predict the future position of our system to within a fraction of an astronomical unit across 2 million years of galactic rotation. Dr. Chen's team reconstructed the launch parameters implied by the data. Assuming an origin around HD 43782, an object of 3I Atlas's observed mass and dimensions would require an initial acceleration beyond anything human technology could produce. Even a small deviation in initial conditions, a miscalculation of 1,000th of a degree in direction or a few meters per second in speed, would result in a miss by tens of billions of kilometers after such a journey. Yet the trajectory intersected Earth's orbital plane with surgical precision. The odds of that happening naturally were less than 1 in 10 to the power of 20. The deeper mystery emerged from what happened next. During its approach toward the inner solar system, 3I Atlas began to decelerate. Not by colliding with particles or through gravitational braking, but in a way that implied active control. Observations from the Deep Space Network and the European Space Agency's Gaia telescope confirmed micro-impulse changes in velocity executed over consistent intervals. These were not random perturbations. The object appeared to be regulating its own motion, as if following a guidance sequence. The deceleration was subtle but continuous, enough to suggest that 3I Atlas was targeting a specific orbital configuration near Earth. Then came the signal. In late July, the Arecibo data archive, though long since decommissioned, was cross-referenced with the new transmissions recorded by the Square Kilometre Array in Australia. Both sets showed an identical narrowband frequency at precisely 1.42 GHz, the natural emission frequency of neutral hydrogen, often proposed as the universal channel for interstellar communication. The signal repeated every 47 seconds with phase stability unmatched by any known natural phenomenon. The repeating structure contained harmonic intervals that followed the prime number sequence up to 19 before resetting. It was as if someone, or something, was using the most fundamental constants of the universe as a calling card. NASA convened an emergency session under the auspices of the Planetary Science Division. Representatives from the Jet Propulsion Laboratory, the European Space Agency, and Japan's JAXA joined the discussion via encrypted link. What the data implied was unthinkable, but undeniable. The object was not just adjusting its motion. It was transmitting. Whether that transmission was intentional communication or automated telemetry remained unclear. Dr. Foster proposed that the modulation pattern might represent compressed data packets rather than a message in any conventional sense. But as decryption algorithms worked through the night, no random pattern emerged. Every bit of information within the signal displayed fractal self-similarity, suggesting deliberate encoding. The global scientific community fractured into two camps. One group advocated for immediate active response, to send a reply on the same hydrogen line frequency. Others, including Dr. Chen herself, argued for restraint. "If we don't understand the structure of the message," she said during a closed symposium, "then sending our own could be the cosmic equivalent of shouting our coordinates into the dark." Her warning carried weight. Humanity had spent decades searching for extraterrestrial signals, but never before had it faced the possibility that something had already found us. Meanwhile, the object's physical characteristics continued to astonish. As 3I Atlas approached the inner solar system, reflected light measurements indicated dimensions roughly 300 meters in length and 80 meters in width. It rotated slowly, once every 2 hours and 38 minutes, maintaining a consistent axis despite solar radiation pressure. More puzzling was its albedo, the measure of reflected light, which fluctuated rhythmically, suggesting segments of its surface were altering reflectivity in patterns synchronized with the signal's repetition. This could have been coincidence, but coincidences are the refuge of those unwilling to face the implications. When the Webb telescope captured high-resolution imagery, what appeared on the screen silenced the room. The object's surface was not irregular or cratered like an asteroid's. It was smooth, segmented, and geometrically precise. Faint seams traced along its equator, illuminated by the sun's reflection. For the first time, humanity was staring at something that appeared engineered. Material composition analysis through spectrography detected traces of isotopes not naturally abundant in our solar system, particularly titanium-44 and osmium-187 in ratios inconsistent with stellar nucleosynthesis. It was the kind of alloy one might construct if one needed a structure to survive the interstellar void for geological epochs. At the SETI Institute, the decoding teams began focusing on the mathematical underpinnings of the transmission. The repetition every 47 seconds seemed arbitrary until Dr. Ilya Komarov at the University of Moscow noticed a subtle drift pattern correlated with Earth's orbital velocity. The signal wasn't static. It was adaptive, subtly compensating for our planet's motion. In other words, 3I Atlas was tracking us. As data poured in, humanity's collective understanding began to bend. For decades, we had dreamed of discovering life beyond Earth, but the reality proved more complex, more chilling. The discovery of 3I Atlas was not a moment of contact. It was a revelation of observation. The object had been en route for 2 million years, and yet its recent maneuvers suggested awareness, or at least programmed response, to our presence. The idea that it could have adjusted its course to coincide with our emergence as a technological species defied coincidence. To achieve such precision, its creators would have needed predictive models of planetary evolution so advanced they bordered on omniscience. Dr. Foster's team at MIT modeled potential launch scenarios. One hypothesis was a galactic survey system, autonomous probes launched toward all nearby sun-like stars, programmed to observe and transmit data upon detecting biosignatures or artificial emissions. If that were the case, then 3I Atlas was not unique but one of thousands scattered across the galaxy, each awakening as it encountered intelligent life. That was the optimistic interpretation. The darker possibility, voiced quietly in late-night meetings, was that the probe was not surveying but assessing. Its long silence during approach, followed by sudden activation once our radio emissions became detectable, suggested a trigger condition. It waited until we were advanced enough to notice it. Further spectroscopic analysis detected faint emissions along its equatorial seams, infrared bursts, synchronized with the signal's timing. These emissions were weak, consistent with low-energy plasma activity, possibly remnants of propulsion systems. They implied the object was not entirely inert. Power was still being generated. But from what source? No known chemical or nuclear process could sustain such output over 2 million years. Dr. Chen theorized an internal conversion system harvesting interstellar hydrogen, while others speculated about zero-point extraction or exotic matter decay. Theoretical physics had finally met its test case in the sky above us. As governments scrambled to form policy responses, the scientific community continued its relentless analysis. Attempts to triangulate the origin of the transmissions suggested that some portion of the signal was reflected, echoed, from deep within the object itself, as if bouncing through an interior cavity. The hollow body hypothesis gained traction. Radar pings from the Goldstone Deep Space Communications Complex confirmed an anomalous delay in echo times, consistent with internal voids. If true, 3I Atlas was not a solid mass, but a shell surrounding something else. Perhaps instruments, perhaps memory storage, or something beyond our comprehension. On September 12th, a small but undeniable change occurred. The frequency of the transmission shifted by a fraction of a megahertz, and within that shift emerged a second modulation, an amplitude pattern matching the mathematical constant E to 4 decimal places. It was no longer just a beacon. It was communicating in the language of mathematics, the only truly universal tongue. The following day, the shift repeated with the ratio of pi. By the third day, prime intervals began embedding within the modulation depth itself. The message was evolving, adapting to our analysis as though aware of being studied. International collaboration intensified. Data streamed through every major observatory and radio array, coordinated through the International Astronomical Union. The sense of competition between nations dissolved in the face of something vastly larger than any single world could claim. Yet as the data deepened, so did the unease. There were no replies to our test transmissions, no acknowledgement, no response, save for continued, precise activity from the object itself. It was speaking, but not to us, or not yet. In the quiet corridors of research centers, scientists began to contemplate the existential implications. 2 million years ago, when our ancestors were barely more than silhouettes moving through savannas, something in a distant system of a nearly identical sun decided to launch a messenger, or a sentinel, toward us. It traversed the interstellar gulf without error, entered our system precisely as we developed the means to detect it, and began to act. This was not coincidence. It was synchronization. It suggested a level of foresight that transcended probability, perhaps even the linear flow of time as we understand it. Was this object a relic of a civilization that no longer exists? A message left drifting through eternity, awaiting discovery by any who could read its code? Or was it active still, part of a network beyond our perception, silently reporting home to a sender that might still be listening? Each hypothesis opened deeper questions. If it was a message, what does it say? If it was a machine, what does it intend? In the end, the science pointed to only one certainty. 3I Atlas could not be the product of natural forces. Its acceleration, trajectory, composition, and signal combined into a picture that shattered centuries of assumption. We are no longer studying a random interstellar rock. We are confronting evidence of intelligence older than our civilization, older even than our species. And somewhere, perhaps 270 light-years away, there may still be eyes, or instruments, watching to see how we respond. The decision of what to do next would not belong solely to astronomers. It would belong to all of humanity, whether to approach, to communicate, or to remain silent. Every option carried unimaginable consequences. What we know now is only the beginning. 3I Atlas has already rewritten our understanding of what is possible. What remains is to discover what it wants. Long before the name 3I Atlas became a headline, it was nothing more than a faint line of motion against a backdrop of stars. Today, it has become a mirror reflecting not just the cosmos, but our own place within it. To understand what this object represents, one must step back and look at the story not only through the lens of data, but through the legacy of the people and instruments that revealed it. The telescopes, the algorithms, the human minds that refused to look away when the universe whispered something extraordinary. At the center of that legacy stands Dr. Sarah Chen. To her colleagues at Berkeley, she has always been known as precise, almost obsessively methodical. A scientist whose intuition is guided by numbers rather than emotion. But even she admits that when she first saw the final trajectory projection, she felt something like vertigo. In the silence of the computational lab, surrounded by blinking monitors and the steady hum of servers, she stared at the plotted path that arced backward through the galaxy and felt the air leave the room. It was a moment of realization that the equations no longer described a random fragment of cosmic debris. They described intention. Chen's career had prepared her for complexity. Her earlier work involved gravitational wave modeling and orbital resonances within multi-body star systems, the intricate dance of gravity where even slight deviations can cascade into chaos. That experience became crucial when her team applied corrective factors for galactic drift and the influence of nearby stellar masses on 3I Atlas's path. What emerged from those corrections was not chaos but astonishing precision. When the simulation was reversed to the point of ejection, the object's velocity aligned with the vector between our solar system and HD 43782, a star nearly identical to our Sun. The probability of such alignment by chance was infinitesimal. The story of this discovery belongs as much to the technology as to the scientists. The James Webb Space Telescope, operating beyond Earth's atmosphere, was the first to resolve the object's surface in detail. Its gold-coated mirrors captured photons that had traveled over 2 million years through interstellar darkness before bouncing off the metallic skin of 3I Atlas and back toward us. Those photons carried history, not the history of Earth, but of another world, another intelligence, another time. Every image released since has been studied frame by frame, revealing not erosion or irregularity, but geometry, angles, edges, symmetry. These are not things the cosmos builds by chance. Parallel to the imaging work, the SETI Institute continued to unravel the signal, its repeating pattern still cycling every 47 seconds with unerring precision. Layers of encoding were discovered, fractal arrangements of pulses that reflected the mathematical beauty of prime number sequences and logarithmic scaling. The deeper the scientists delved, the more it seemed that the signal was less a message and more a test, an evolving construct that mirrored our own analytical progress. As we decoded one layer, another appeared, as though it were gauging our comprehension, adjusting its complexity to match our capacity. This adaptive behavior suggested not only intelligence but awareness, an algorithmic consciousness that had been dormant for eons, now awakened by observation. Meanwhile, engineers and mission planners began to consider what once would have been impossible: direct exploration. Concepts for a rendezvous mission were drawn up in the quiet rooms of NASA's Jet Propulsion Laboratory. They named it Project Echo, a nod to the idea that humanity might, for the first time, reach out to something that had been listening for longer than our species had existed. The proposal involved a nuclear-powered probe capable of reaching the object within a decade, equipped with autonomous systems designed to avoid provoking unintended responses. Yet within those same planning meetings, unease persisted. How do you prepare for contact with something that might be older than civilization itself? Public fascination grew as the story reached beyond scientific circles. For the first time since the dawn of the space age, humanity's gaze unified on a single target. Amateur astronomers tracked 3I Atlas from their backyards. Schoolchildren learned its trajectory as if it were a new planet. And through it all, one question lingered. What happens when we finally understand its purpose? Among those who sought meaning in the data was Dr. Helena Foster at MIT. Her comparative analysis between 3I Atlas and Oumuamua revealed something deeply poetic and deeply unsettling. Oumuamua, she said, was like a drifting leaf carried by cosmic winds. 3I Atlas was a compass needle. It pointed, it guided, and perhaps it waited. Foster believed the probe was one node of a larger network, a system spanning multiple star systems, each device awakening only when certain criteria were met. If that was true, then we were not observing the first probe. We were witnessing one link in a chain that could encircle the galaxy. As weeks passed, evidence mounted that 3I Atlas was no longer coasting. Subtle variations in its light curve suggested internal movement, shifts of mass within the structure, possibly reconfiguration of internal systems long dormant. The signal's amplitude began to fluctuate in synchronization with the object's rotation, as if components were aligning with Earth during each cycle. Some called it coincidence. Others whispered that it was acknowledgement. At Berkeley, Dr. Chen's team built predictive models of the object's future behavior. The results hinted at stabilization into a near-Earth orbit within several months. That realization sparked an ethical debate that rippled far beyond the scientific community. Should we intercept? Should we communicate? Should we hide? Humanity had always wondered if it was alone. Now that the question might finally be answered, fear began to replace curiosity. The possibility that the probe was observing, evaluating, or transmitting data to an unknown destination gnawed at the edges of global consciousness. Yet in the quiet moments, among those who had devoted their lives to the stars, awe outweighed fear. The existence of 3I Atlas meant that intelligence was not confined to one fragile world orbiting a yellow star. Somewhere, across 270 light-years of space, there had been others who looked up and wondered the same thing. They possessed knowledge beyond anything humanity could imagine, mastery of propulsion, material science, and predictive modeling that allowed them to foresee our rise from stone tools to telescopes. Whether they still existed or not, their act of creation had reached across eons to touch us. That realization reshaped the very foundation of human identity. In lectures and symposiums, philosophers began to speak of 3I Atlas as a form of cosmic archaeology, a discovery not of alien life, but of alien intention. Every generation has its defining revelation: fire, flight, the atom, the genome. This was ours. The difference was that it didn't expand our world. It expanded our perspective beyond the world entirely. As researchers continued their work, one question persisted in every conversation. If it was launched with purpose, what was that purpose? The possibilities remained open and vast. It could be an emissary of peace, a scientific instrument seeking knowledge across the stars. It could be a relic of a civilization long extinct, its creators lost while their machine endured. Or it could be something more complex, an observer designed to awaken only when a civilization reached a threshold of awareness, to record, to judge, to decide. Even as those debates raged, the signal changed once again. The repeating pattern began to overlay a second harmonic, faint, almost imperceptible, but mathematically perfect. The waveform corresponded to the hydrogen spectral line multiplied by the ratio of pi to a, an impossible coincidence that implied deliberate composition. Then, for the first time, the transmission paused. 47 seconds passed, 94, 141. Then it resumed with a new sequence. The Fibonacci progression, encoded in amplitude. It was as if the object had listened and responded, subtly shifting to show comprehension. Dr. Chen watched the pattern unfold from her console at 3 in the morning. Around her, the control room was silent except for the faint hum of electronics. The realization settled slowly, almost tenderly. Something was answering. Not in words, not in language, but in mathematics, the shared grammar of the universe. For the first time, humanity was not speaking into silence. The silence was speaking back. 3I Atlas now occupies a stable orbit beyond the moon, a silent companion visible through powerful telescopes, a gleaming reminder of how small and extraordinary we are. It does not threaten. It does not flee. It waits, suspended in the balance between mystery and revelation. Engineers continue to refine the design for Project Echo, but even if the mission proceeds, it may take decades before it reaches its target. Until then, we watch, we listen, we learn. Perhaps that is what the creators of 3I Atlas intended. Not immediate contact, but reflection. A mirror cast across the stars to make us ask who we are and what kind of civilization we might become. In the end, the object's greatest gift may not be knowledge of them, but a deeper understanding of ourselves. As the